Okay, in this demo here, we're going to be looking at another separation technique known as solvent extraction. This piece of glass right here is known as a separatory funnel. You'll notice like a barrette on the bottom, there's a stopcock valve here. As long as the stopcock here is perpendicular to the nozzle, we know it's currently in the closed position. Like a barrette though, you can open and close it to dispense solution accordingly. For this method here, it's very commonly used to extract chemicals that have already been dissolved. So because things are fully dissolved here, a method like filtration wouldn't work. It's not like a solid can be trapped by a piece of filter paper here. For this demonstration here, I'm going to imagine starting off with a solution of just water. I'm going to imagine my chemical has unfortunately been dissolved inside. Okay, so it's already fully mixed in. Because we're just sort of such a uniform solution here, we can't use any other separation technique currently. What I'm going to do here is I'm going to just add a little bit of food coloring so you can identify my starting solution here as the water. So just going to drop in a little bit of food coloring there. You can actually cap the separatory funnel. As long as it's closed on the bottom here, let's just lift the separatory funnel here. You can actually rock this back and forth. Okay. You're going to see later on when I do this rocking here, sometimes there's a little bit of pressure that builds up here. So just every now and then we just open and close this to let out a little bit of the pressure. In this case here, it is just water, so not too much pressure built up right now. So my solid chemical here has been fully dissolved here. We're in this mixture. I want to somehow pull the solid out of this water solution here. So I'm just going to uncap this again here. We're going to be adding, as the name suggests here, liquid-liquid extraction. I'm going to be adding another liquid. Now in this case here, I know water is polar. This second liquid that I'm going to add has to be non-polar, because I know a non-polar thing here will, like oil and water, separate eventually. The non-polar compound I'm going to be using here is called petroleum ether. Okay, it also is a clear solution. So we're just going to add a little bit of this petroleum ether. And as you just think about sort of which liquid I should be adding, not only does it need to be like oil and water here, it has to separate into two different layers. You actually see that already. The petroleum ether is on top here, the water layer is on the bottom. We had to make sure we choose this liquid so that the solid actually preferentially dissolves. Let's say for argument's sake here, I had it previously dissolved in water, but let's say it actually dissolves better in the petroleum ether than the water. At the moment here, you see that the two layers here are completely separate. What I want to do is I want to temporarily suspend the solutions, temporarily mix the solutions so that the chemicals that have been dissolved in water will slowly transition to be dissolved in the petroleum ether. So just like I showed you before, you're just going to cap the separatory funnel here. You notice the valve is closed. You're going to rock this upside down here, rock it back and forth a couple times. This time here, it might actually build up some pressure. So again, every now and then, I'm just going to open and close the valve here. Just make sure you close it when you rock this back and forth. Okay. All right. So again, open. If you listen closely, you can actually hear that buildup of pressure. Okay. So just rock this back and forth. I'm just giving the solid a little bit of a chance to actually dissolve into the petroleum ether instead of the water. Okay. So just rock this back and forth. Okay. And again, just let out some of the pressure. Okay. Okay. What I'm going to do here is I'm going to put this back here on the ring stand. Okay. I'm going to let the sort of polar, non-polar do its work here. The non-polar petroleum ether is now sitting above the water. Because I had rocked it back and forth, some of the solid that was previously dissolved in the water is now going to have preferentially dissolved into the petroleum ether. I let the two layers separate, and because they are separated, I can actually just open the stopcock valve here so that we can actually let out one solution at a time. So I'm just going to let out a little bit of the water first. Okay, might actually help because the valve here is currently sealed, so there's a lot of pressure buildup here. It's not letting the solution out. So let's just open up this valve here, and therefore you can just put this down. I just want to collect up the water. Okay, I want to make sure all the water is gone from the petroleum ether. So I'm just going to make sure all that blue here eventually separates. Okay, I might have a little bit of petroleum ether left behind. That's totally fine. I'm going to assume here this was here. The solid is now preferentially dissolved in the petroleum ether, and now I can just swap out the beaker. This might still be a mixture of still water and petroleum ether, but assuming that this is now just a petroleum ether left behind, we're just going to collect the petroleum ether into a totally separate beaker here. Okay. Now you'll notice here I still have traces of blue. Okay. So it wasn't a perfect separation here, but again, because the solid has preferentially dissolved into the ether, this one here is now my solid in a totally different liquid here. With this case here, because I had just ensured that all the water, there's a little bit of food color left behind, but because I've ensured all the water has gotten through, I may have actually left out a little bit of petroleum ether. This now also represents a mixture of the two liquids again. So what I can do here is I can actually pour this through again. So take your solution. This is currently our mixture, okay? You'll notice here you actually do still have petroleum ether. I have about that much that has gone through, but just like before, I can rock it back and forth. I may even pour in a little bit of fresh petroleum ether so that, again, I can preferentially dissolve the solid into this mixture. So just gonna add a little bit more petroleum ether here. That's totally fresh, so that means the chemicals, the solid hasn't dissolved into that extra layer yet. And again, just like before, I can do the temporary suspension here, seal the top, rock this back and forth. Again, every sort of 2 or 3 rocks here, you're gonna let out a little bit of the pressure, close it again, rock it back and forth. Okay. Again, I've chosen this, these 2 liquids here, they're immiscible in each other. Okay. And also that the solid is preferentially dissolved into the one more than the other, okay? And that's how, even if the solid is completely dissolved, we can actually separate one layer from the other. Usually we do this separation technique here 2 or 3 times, and if you just do the math of it here, we would have pulled out quite a lot of it by the 3rd separation. So again, I'm just gonna open this valve here. Just remember, always open this top here so that we let the solution through. And again, I'm just going to see if I can open this valve here, collect up all the water. Okay, I'm gonna maybe have collected a little bit of petroleum ether, but now I have just pure petroleum ether with my compound dissolved into it. I swap this out for my second container here, and now I just have my solid should be dissolved in pure petroleum ether. Okay, thanks guys.